how can you quickly memorize polyatomic ions? So first we can classify it into oxoanions. And there are a family of 2 oxoanions, and there are also families of 4 oxoanions. So we'll start with the 4 oxoanions. Some of the examples would look like ClO minus, ClO2 minus, ClO3 minus, ClO4 minus. So first, to define an oxoanion. An oxoanion has an oxygen and an anion, which is just a nonmetal. So that means it doesn't have to be chlorine plus oxygen. It could be bromine plus oxygen or iodine plus oxygen, but they wouldn't be called iodine, oxygen, or anything. They have special names. So we'll jump in straight into it. So whenever you see an oxoanion, and these are family of 4 oxoanions, which means their oxygen can hold from 1 to 4. Whenever you see there's a 3 on oxygen, its ending will be be 8. So we're going to say the anion and an 8, chlorate. When you have 2 oxygens, it will end with it. So chlorate. So then for 1 oxygen, we base it off of it, but we add a little something in front of it. We call it hippo something it. So hypochlorite. Now for 4 oxygens, we base it off of 8, but we add a little something in front of it, and it becomes per something 8. In this case, perchlorate. So for example, if this were bromine instead of chlorine, we would say hypobromate, bromate, and perbromate. If it were iodine, we would say hypoiodite, and I think you get the idea. So when it's 2, we kind of base it off of it and then add hippo. And if it's 3 and more, we base it off of 8 and add per. So that's your family of 4 oxoanions. Now, family of 2 oxoanions are a bit more different. So it look like phosphorus, sulfur, or nitrogen plus an oxygen, all right? So phosphorus plus an oxygen, because oxo is oxygen, anion is anion. Phosphorus plus oxygen will give you phosphate. But if it has a 3, it's going to be phosphate. So the thing is, 2 oxoanions, I'll just write it out for you. And we also have sulfate and sulfite. We'll figure out the pattern in just a bit. And we also have nitrate and nitrite. Now, we see that their oxygen numbers are a bit different. So where there is a anion that can only have 2 oxoanions, 2 forms of it, we call a smaller form. The smaller form, which is the one with least oxygen, the smaller form will end in it, and the bigger form of the oxoanion will end with 8. So if it's a oxoanion, if your nonmetal belongs in, if your polyatomic ion belongs in the family of 2 oxoanions, you won't be following this pattern anymore. It's not like you have 4 oxygens here and then you're going to add per in front of it. No. But if it's a family of 2 oxoanions, like in this case here, you're going to follow this pattern, where if the smaller form of the oxoanion, the smaller form having less oxygens, that will get it ending, and the one with more oxygens will get 8 ending. So in this case, it would be phosphorate and phosphorite. In this case, it will be sulfate and sulfite. And then this will be nitrate and nitrite. So what you do need to memorize here is how phosphorus will start with 4 and 3, sulfate start 4 and then 3, but nitrate will start with 3 and then 2. So we've worked with nitrate a lot, so we just remember nitrate, we remember sulfate, we remember phosphate, and then we kind of know that we just memorize the ones that have more oxygens. So then you would know the next one after this oxoanion will be the one with one less oxygen. That's one tip to help you remember it. The other tip when you write it out is the charge. You notice how the charge here remains constant. You got this group of oxoanions. They have different oxygens, but they still have the same charge. That is a trend for family of 2 oxoanions. Now, moreover, what if we added a hydrogen in front of these oxoanions? Then something different would happen. So let's work off a phosphate. What if we said HPO4 2 minus and H2PO4 minus. I'll explain the trend for when you add a hydrogen just a bit. And what if for sulfate, you added a hydrogen in front of it? So how do you remember these ones? Okay, so the trend for these ones is when you add a hydrogen in front of one of these oxoanions, your oxygen will remain the same, but your charge going from oxoanion to adding a hydrogen in front of it, your charge will decrease by 1 based on the number of hydrogens you add. So one more hydrogen you add, 1 less net charge. And likewise, you added 1 more hydrogen, so then you lose 1 more charge. Same thing for here, sulfate going to hydrogen sulfate. Your oxygen still stay the same, but your net overall charge will decrease by 1 for every hydrogen you add. Net charge decreased by 1 for every hydrogen you add. The oxygen numbers will stay the same. And for oxoanions, their charge will be the same for the varying oxygens that they end up having. Okay, so now that you know the pattern for writing these oxoanions plus a hydrogen, what are their names? So we know that PO4 2 minus, it's going to be hydrogen phosphate because it has 4 oxygens, so we're going to follow this name, but I add a hydrogen in front of it, so hydrogen phosphate. Same name, but add a hydrogen in front of it. What about this one? It's dihydrogen phosphate because there's 2 hydrogens, dihydrogen phosphate. No rocket science here. What about this one? We see there's 4 oxygens, so it's based off of the name sulfate. Now it's going to be hydrogen sulfate. That's your name. And sometimes they will also call it something different, bisulfate. Bisulfate. Just to say that there is a hydrogen in front of it. Sometimes they do that, such as in the case of 2 more polyatomic ions that we're going to look at, just to help you memorize everything you could possibly wish. Okay. So what about there are other polyatomic ions? Chromate and dichromate. You see that when we say dichromate, that means there's 2. Likewise, here we said dihydrogen phosphate. When we say di, there's 2. So dichromate end up having 7, but the charge will stay the same. As we said, the pattern charge will stay the same. However, the oxygens, you just kind of have to memorize it. So we got chromate and dichromate. And we also have permanganate, MnO4 minus. That's an easy one to memorize. And one other one, the last one we're going to talk about today is carbonate. Carbonates. This is also little bit of an exception from 2 oxoanions and 4 oxoanions, so that's why I put it on out of the scope here. Just remember this is carbonate. You can just have to like memorize it. And hydrogen carbonate. Hydrogen carbonate. So you see how this one, the pattern for carbonate, how when we add a hydrogen in front of it, the oxygen stays the same, but your charge will decrease by 1. Just like what happened here. Whenever you add one more hydrogen in front of your oxoanion, your charge will decrease by 1. Everything else stays the same. If this video was helpful to you, make sure to hit a like.